Welcome back to the PolicyViz podcast. I'm your host, John Schwabish. Now, if you're anything like me, you're probably not a big fan of using 3D effects in your data visualizations. Whenever you see that 3D exploding pie chart, everybody makes fun of it. It gets a lot of critique on social media, but there are times when 3D can be useful. And so, on today's episode of the podcast, I am excited to have Tyler Morgan-Wall as my guest to talk about his use of 3D and animated 3D in his data visualization efforts. Tyler created the rayshader package in R, and he uses that package to create what I think are some pretty astounding visualizations. Tyler also has a background in physics, so he brings that background to the development of the package and to his work more generally. So we talk about his work, we talk about his background, we also talk about a run-in he had with Edward Tufte making fun of one of his recent data visualizations. So check out this week's episode of the show. I think you're going to learn a lot. If you're an R programmer, I hope you'll go check out the rayshader and the rayverse packages so you can create your own 3D in useful ways and helpful ways, and to help people better understand your data. So here is my conversation with Tyler Morgan-Wall on this week's episode of the PolicyViz podcast. Hey, Tyler, how are you? Welcome to the PolicyViz podcast.
Great. Thanks for inviting me.
Very excited to have you on the show. Very excited to be doing a nighttime podcast, not one of my regular things. So I've got my glass of whiskey here. For those listening, you can hear the ice. If you're Steve Wexler, you're mad that I have ice in my whiskey, but I like my whiskey cold. So that's what we're going to do tonight. Tyler, I kind of stumbled upon your work a couple of months ago from this explosion. You had this really cool visualization that Edward Tufte pounced on, and we'll talk about that in a little bit, but I don't want to spend too much time talking about the negative. I want to talk about your amazing work. And, you know, usually for podcasts, I'll sort of introduce people and then just go to the tape, but I actually feel like you have a really interesting background. So maybe you could talk a little bit about your background, and then, because I know you have this background
Sure.
in physics, and then just maybe just segue into the dataviz work that you've been doing, and how those two sort of merge together, because it's a really interesting combination of skills.
Yep. So yeah, I got my PhD in physics from Johns Hopkins in condensed matter, basically superconducting quantum nano devices. So experimental, a lot of lab work. It was very. I really enjoyed working in the lab, but like many people who work in physics, I ended up kind of pivoting to data science work afterwards, like the quote unquote traditional path, where it's a lot of kind of orthogonal schoolwork to then end up doing data science. Right. But in doing that, I had a lot of sort of analytical training. But I ended up working at a place in DC called the Institute for Defense Analyses, which we do a lot of work with the government for data science work and analytical work. And part of that was I was surrounded by statisticians. And when you're surrounded by statisticians, it's inevitable that you end up learning R. So I ended up, I didn't really have a background in using R, and I'd used some Python in my graduate studies, but I ended up starting to use R, and then and from there I started building some packages, and then I found out, this is really great. It's really easy to kind of take a package and then produce it so other people can do reproducible workflows, and you make it so other people can use your work a lot easier than like sharing scripts or Python scripts or stuff like that. And then at one point, I had just come back from the RStudio conference presenting on a kind of dry statistical package that I'd been developing with my work. And I just had the desire to do something more fun. And I'd always been interested in mapping.
Right.
And so I decided to try to produce a package that would create maps in R. And that is how I started writing the rayshader package.
So that's really interesting that like you went to maps right away. Was there a reason? Like you have this incredible background, but it's not in cartography. Was
Right.
maps just like,
So
oh, maps are great, maps are cool, everybody loves maps?
yeah, I mean, part of it was just like I had always really out of all the kind of uh, areas in data visualization, I had personally just always enjoyed a good map. Uh,
Sure, yeah.
but like the it really was more just that I wanted to learn more about cartography,
Okay.
and I had a very specific sense of what I thought an interface to make maps would be programmatically. And part of my desire to write rayshader was I originally looked around for something like what I had in my mind, which is
Mm-hmm.
basically building up maps based on layers of that all of the maps aspects really come from the elevation
Mm-hmm.
data. There's a lot of tools like QGIS and a
Right.
lot of GIS software, which are really complex, powerful tools, but not really are focused or have the focus on kind of a programmatic interface.
Mm-hmm.
So I really like that kind of reproducible workflow
Yeah.
when working with dataviz. I think that's a really important thing to have, and I think it's really good if tools support the reproducible workflow. I think they eventually become sort of higher quality in that you can you're less likely to kind of make mistakes along the
Sure.
way. It ensures a kind of better end product. Um, and it ends up being, I think, a lot less work for the practitioner if you have a tool that you can just kind of change the data source, and you get an identical visualization now, but just with a completely different area or something like that. And there's nothing really like that for maps
Mm.
that I found. So I was like, oh, I'm going to start building something. And the second part of rayshader was I'd never really found a tool that was really focused on making beautiful maps.
Mm.
It was mostly focused on sort of putting together maps for not saying you couldn't make beautiful maps in something like QGIS, but the focus is more on the technical
Yeah, right.
cartography
Yeah, I
aspects.
gotcha. Yeah.
So there was nothing really out there that was really focused on that. And I thought, hey, path tracing or ray tracing, I've seen lots of really beautiful stuff made with that. So maybe if I combined sort of cartography with ray tracing, I would get something really cool out of it.
Yeah.
And that was my thinking going into it. And that's kind of where the genesis of the name rayshader was. It was ray tracing plus hill shading.
Right.
And it ended up being a really boon to rayshader that the rayshader.com was available.
Right. So you're like, you're like the Kleenex of the mapping world.
Yeah, when I saw the first person use rayshader to refer to a map that wasn't made with rayshader, as in like, oh, I'm going to rayshade this, and it was some other thing,
Yeah.
some other program. I'm like, oh wow, I'm the Kleenex of ray traced maps.
Yeah.
So that was it was a really good name. Sometimes you just like hit on a really good name.
Yeah.
And you don't really realize it, and that can really be a boon, especially early on,
Right.
Because it was one of those things where I think people just kind of knew right away, like, oh, like this makes maps with some form of ray tracing,
Right.
and and having a name that kind of tells you what the program does is just it just really helps, I think, from the marketing
Sure.
aspect,
Yeah.
which I found is a big part of a successful kind of package for dataviz.
Yeah. So I want to come back to this idea of building packages. It is interesting to me that you sort of take this approach of, I'm going to build a package that people can install and use, as opposed to building out a set. It sounds like, at least, and correct me if I'm wrong, it sounds like you start on the side of packages as opposed to building out sort of a set of scripts, publicly at least, and then getting to a point where people are like, this would be really great if it was a package, and then you build the package. It sounds like you take what I sort of view, and I could be wrong, is the kind of opposite approach or steps to that.
Right. Well, that I think is the great thing about the R ecosystem.
Yeah.
Is that unlike a lot of programming languages really do kind of work, their bread and butter is kind of sharing scripts, but R has this packaging mechanism built in where that really is just sharing scripts, but in like a better, more standardized way,
Right.
with kind of lots of checks from the CRAN and stuff that makes it much easier for the end user, documentation built in. And because I had done this work with my job building packages, I had kind of gotten over that hump of learning how to do that, how to transition from scripts to packages.
Mm-hmm.
Um, and because I knew how to make a package, and I knew it, and it really isn't that much of a jump
Sure.
from writing scripts to doing that, then to me, it's the first step is, hey, if I'm going to share this with anyone else, I'm going to make it into a package
Right.
because then it makes it one, a lot easier to install.
Right.
Two, it gives it an API. People know how to call the documentation and help files. I can get this great environment of like building package down websites for
Mm-hmm.
documentation. Because I can run a CRAN check, which is a way the checks that the CRAN repository they use to kind of ensure the software quality that it runs on multiple systems. I can run that and know that it runs on Macs, Windows,
Right.
Linux. It's just a lot of benefits get from packaging that you don't necessarily get from scripts.
So do you, if you had your way, if you were the R chancellor or whatever we would
Yeah,
call it, like the god of R,
benevolent
the
dictator.
benevolent dictator of R, would you have everyone, instead of sharing scripts, would you have them write packages, or do you think, it sort of works like, it sort of works the way it is? Some people just share scripts because they don't, because it is, I mean, you sort of blew by the fact that like you have all this documentation, you have a help file, and you have all these like things. Like that's not easy to do,
No,
and
no.
it takes a lot of work and time and effort, and you're providing that to the community. So, like, if you had your druthers, would you say everybody should, for every script that they're putting publicly, it should be a package? Given, of course, that they would have to
No,
write all this other stuff.
yeah, no. I would say. I mean, so there's kind of like a certain level of um, how much do I intend for other people to look at this as kind of learning material,
Right. Okay. Yeah.
and how much do I think of it as a tool?
Yeah.
So if I look at this as like a tool to create some sort of standardized output, like rayshader produces 3D
Right.
maps, and or rayrender renders 3D scenes, or some it's a level of both complexity and kind of the intention. Whereas if I'm just sharing a script to show, let's say, how I made an individual dataviz,
Mm-hmm.
like let's say this is how I made this specific
Right.
map. I mean, that's obviously you don't need to have a package for that. This is like, here's how I made this specific visualization. That's the perfect opportunity for sharing a
Yeah.
script. But if I mean for it to be a tool for other people to use, then yeah, I think packages are kind of the best
Right.
way to deliver that to other people,
Great.
at least in
Yeah,
R.
yeah, that's great. So let's go to these two concepts really of 3D and
Yeah,
animation. So 3D, I think oftentimes gets a raw deal in dataviz, but
yeah,
usually appropriately so when it's sort of that, those Excel 3D cones garbage thing.
right.
So I just want to give, sort of just open it up, and like, your thoughts on 3D and your perspective on
Sure.
when it's useful.
So I think 3D had kind of suffered from a chicken and the egg problem,
Mm,
because early on, computationally wise, we didn't have the computing power, in the early 90s to produce like real 3D visualizations. I mean, 3D wasn't really a thing. So a lot of the tools we developed on early on, like, the Excel and the bad sort of 3D visualizations were really these, kind of extreme, or this, the 3D bar charts or 3D pie
yeah.
charts. Like they weren't real 3D in the sense that the data wasn't 3D. It was just window dressing.
Right.
And I think from years of having only that capability, and the sort of like a meme of 3D charts are bad,
Yeah.
kind of permeating dataviz, was because the tools only supported in early on bad dataviz. So from that point, tool makers weren't going to put in the effort to support nice data visualizations
Hmm.
that are 3D. So if you don't have anyone pushing the tools, then all you have are these kind of poor 3D data visualizations. And I think a lot for many years we were kind of the major tools didn't really support 3D in any real good way. I think in the mid 2000s, what happened was people, like individual, very talented people, started using tools like 3D modeling tools, and renderers like Blender,
Hmm.
to start to create like really kind of striking visualizations. I know one of the first people to do 3D maps, I believe, was Scott Reinhard of the New York Times, and he produced some really gorgeous maps from that. But each one is kind of like an artisanal. The tool's not designed for that.
Yeah, yeah,
It's a renderer. It's designed for people doing CGI, movie
yeah.
making,
Mm-hmm.
3D modeling. It is not a tool meant for data visualization. It's not like built in to an ecosystem that supports data very well.
Right.
So for a while, then we had this kind of artisanal period of people being able to build 3D visualizations, but using tools that weren't really meant for that. And I came in and really wanted to create some tools that would natively within R support producing these sort of visualizations that you only really saw like advanced 3D rendering software like Blender create before.
Yeah.
With and only a couple lines of code. So that was kind of my goal. Originally, it was to create maps, and actually, so originally it just was to create really cool looking 2D maps. But
Yeah.
there was a part where I suddenly thought like, hey, this would be really easy to make 3D. So I sat down and I just made one of these 2D maps that I made with like ray tracing and hill shade and these like color hill shading algorithms, and extruded it to 3D from the 2D map. And I remember just looking at it being like, oh my God, this is amazing. Like literally, I've never seen anything like this before. Like and it wasn't that complex at the time.
Yeah.
It was just like, hey, I'm just mapping this texture onto this 3D surface. But I realized that like, hey, this is something I've only really seen in kind of like bespoke, hand drawn diagrams from the USGS. It's actually a very common sort of aesthetic that in the a lot of geospatial work is kind of these slices through the earth.
Right.
But no tools really supported that. So a lot of these things were like handmade in Illustrator or hand drawn. Right. And once I sort of created a tool that could make these from the data directly, not like I thought it was really cool, and then releasing it to the public in a package form. A lot of other people started using it and started making some really cool stuff with it as well.
Yeah. Let me just to give folks a sense. Can you give me a ballpark of how much computing power and how long it took for that first one to go from like this 2D map to building it up in rayshader? Like, when you click go, when you click run, like, I think there's probably people listening to this and like, well, my Mac can't handle something like this. It's building this spinning globe with all this stuff, but I've seen your work, and I'm sure that's not the case. So, like, can you give folks like an idea of what they can expect when they dive into the package?
Right. So there's actually two different packages. So rayshader, right. So there's actually multiple rendering methods, and that's been half of the difficulty in doing this is there you developing these packages. I actually have to read a lot of computer graphics literature to figure out how to like write the software. I mean, it's enough. I'm doing kind of double duty with a lot of this stuff because not only am I trying to prophesize why 3D data visualization is good, but I also have to write the tools at the same time. Right. So it's having to do the technical part of writing the tools and then also create engaging visualizations.
Right.
So like it's a lot of balancing that back and forth. But I would say the actual computing power isn't really that high. I think most modern computers have like enough computing power to support the basic stuff that rayshader does, which is creating the sort of basic 3D maps. The hard part is when you use so rayshader has a function called render high quality, and that calls rayrender, which is a high quality path tracing renderer. And that can take a while. Like that's one of those things where an individual frame could take 10 minutes to render, because it's using it advanced. It's basically simulating how light transport acts through the scene. So it's actually bouncing around with the equivalent of photons, and then drawing the scene from those. So it's a very complicated algorithm. So that can take a while. But the normal 3D plots, you can make a 3D plot instantaneously. It's just if you want these like really slick looking 3D ones that looks like light. Then it can take a while. But that's computational work. I would say lines of code wise, we're still only talking like a dozen or 2 dozen lines of code for even the most complicated things. Like if you look at my GitHub gist page, so the visualization that went viral and it reached like the number one page or the number one slot at the top of Reddit, and that Tufty tweeted about, that was about 40 lines of code, and it's not really dense code.
Right.
You can read through it, and it really isn't that bad.
Yeah.
So computational, I mean, that's something, if you really were interested in speeding up, you could always even like rent an AWS server.
Yeah.
I've had people do that. They've actually rented like AWS servers with 32 CPUs or 64 CPUs and rendered something really quickly. I just will render something overnight.
Right.
And like with my computer, like that's,
yeah.
I just take like 8 hours, be like, okay, this is my allocation, 360 frames, 30 frames per second. That means I have, a minute to spend on per frame approximately.
Yeah.
So then I just scale the quality of my render down to reach that time frame and render that. So that's how I do it.
Yeah. So I do want to get to this Tufty thing, because I think it's example of a lot of different things, but clearly you building the package is built on your physics background. Did you come to a point when you were building it where you're like, how do I want to ask this? Like, did you get to the point where you're like, well, the physics here is like not totally perfect, so I'm going to spend a lot more time figuring it out, or it's good enough, but like at your core as a physicist, you're like, ooh, this hurts me to like cut this little corner here. Like, how did you like balance that? Like,
well, yeah. So there's actually, so the original rendering method that I used, which was just kind of the out of the box sort of more traditional CGI approach that wasn't based on path tracing, that definitely had some kind of workarounds where you kind of hack to get something looking physically accurate. Right. There was one part where I had the shadow that was cast that was just me basically hacking together like a darker version of the background.
Okay. Yeah.
That underneath, it wasn't a real shadow, there wasn't any actual lights going on.
Yeah.
But it was, and that to me, that sort of not looking kind of quote unquote realistic really motivated me to develop the path tracing approach, because there you can get the things where it looks like you have like the actual sun is shining down. Like there you could actually see like, this is where the sun's position is, the sun's size. Like you could make calculations based, for like solar panel, coverage based on that. And the path tracing stuff is actually really, it's based on, it's physically based rendering is what it's referred to as, PBR. And what's nice about that is, so it's a Monte Carlo method that converges on sort of looking physically realistic. If given you take a number of samples, it's a Monte Carlo method, so you have to take a high number of samples, but eventually it all integrates out to looking like it's a photograph. And the nice thing about that from debugging, actually, from a programmer point of view, is if I render something and I'm like, hey, that doesn't look right. I can be like, oh, it's because there's a bug somewhere.
Yeah.
So it's actually easy to debug, because I'll just like take a picture of something and see like, hey, that shadow looks wrong.
Right.
And then I'll actually go in and be like, oh, it's because, I got some sine or cosine wrong, and it's in the wrong, angle. And a lot of my early debugging was like, hey, this doesn't look right. And they'd be like, oh, it doesn't look right because it's not right.
Yeah.
But now it's actually the physicist part of me is very satisfied, because physically based rendering really does produce results that are pretty close to reality. And there's lots of, complex integrals related to radiance. And a lot of the techniques actually came from like nuclear physics. And you can actually read the physics papers, in which that's part of my physics background is, interpreting all this. So I'll go back and read these papers to figure out where it's all coming from and be like, oh, okay, this all makes sense. And I know, and as a physicist, I mean, really, like I know economists also kind of have this stereotype where you look at somebody else's field and you go like, oh, I can do that. Like I can understand this. Yeah, and this is I'm lucky in this sense, in that because it's physically based rendering, I can actually read these CGI papers and go like, oh, this is physics. So I got you, even though it's completely different genesis,
but I can still
for the field.
We can still talk.
It's like, exactly. So I'm but that itch is well scratched.
That's great.
By this rendering.
That's great.
Stuff,
That's awesome. Okay, so let's turn to Tufty. So I'm going to just read a little bit from my notes here so people know what we're talking about. So in September, you created this really cool animated map. It showed I had to write this down. Submarine fiber optic cable network around the world, and so it was this
Yep.
just to sort of paint the picture for people. It was this spinning globe, and it had basically lines around it. If hopefully folks sort of get the idea there. And then Tufty put out this tweet, and I'm going to read this tweet for you, and then we don't have to spend a ton of time bashing him, although I'm happy to do that if we want to spend some time. But so this was Tufty's tweet. I'll link to it in the show notes so people can go look at it. So Tufty tweets out, discovery of backwards Earth rotation. He puts a little arrow, Nobel Prize. Diameter of each optic cable apparently about 100 miles, exclamation point. On land, drop shadow cable stacks reach far out in outer space. Displays of space junk have same problem. Perhaps thinner lines reduce the massive exaggeration. So, yeah. I mean, I guess I'll just put that out there and
yeah.
What was your I guess first question is what was your reaction when you saw him retweet that?
So my first reaction was, I've made it. Tufty has criticized my tweet. It's from that point to get it really was I looked at it. I just scanned what he wrote. Right. And when I scanned it, I didn't see what I was afraid of.
Yeah.
The only thing that I was afraid of was he would tweet something about disparaging 3D visualization in particular, because then that just kind of, there's a lot of people who follow Tufty who think 3D is bad, and I just didn't want to have to fight the battle of oh god no, I have to somehow debate Tufty, and or at least people who follow him that 3D is fine. The fact I read that and I did not see anything that was related to 3D in particular, so I breathed a sigh of relief. I was like, okay, he's having some kind of snark about that. Whatever. Right. Oh, thank God. And then I kind of read it over a couple times, and I was like, okay, yeah. A lot of people say I had some other data visualizations that had gone viral earlier on, where the Earth was rotating the wrong way.
Yeah.
Where apparently you're not allowed to spin a globe in two different ways. You're contractually obligated always to spin a globe one way and not the other. Right. I never considered this to be a physically accurate representation of Earth's orbit around the sun. You might also notice I had no clouds.
Right.
I didn't render the star background.
Right. That's right.
I didn't render the moon going in and out. There's a lot of things that wasn't physically accurate. But
I'm sure NASA's super pissed about the whole thing.
Yeah, I don't think anyone was looking at this visualization going I could really understand this submarine cable map thing, but what planet is this on? Obviously not Earth, because it's rotating the wrong direction. Yeah. I'm very confused. Yeah. I had a lot of people posting hey, this might confuse some people because the Earth's rotating the wrong way. Just who's what are they confused about?
Yeah, right.
Anyway, that's besides the point. But then I looked at it. So he mentioned the thickness of the cable, which I thought was a little confusing. So these actual submarine cables are about a garden hose thick, which I don't know if you've ever tried to see a garden hose from space.
Yeah,
but it's very difficult. I'm sure. I'm sure people would love to have a telescope in space of that resolution, but the GIS or geospatial work mapping is full of abstractions. That's a dataviz. We have lots of abstractions. It just more confused me that he would focus on that, because I'm like, what is this? To me, it was I had a hard time figuring out if this was a funny snark thing, Tufty, because I don't know Tufty, and I don't know. He might have just seen this as I'm being funny, but the fact that he used the word drop shadow, I'm like, oh, he's kind of interpreting this from a 2D perspective, because this isn't drop shadow. This is path tracing. That's actual shadows. Right. Yeah, it's just shadow.
Right.
So for me, I could see him kind of interpreting it from the 2D perspective.
Yeah.
The fact that he used that, and yeah, the fact that it was that we had these kind of abstractions that we use in GIS that might not represent the same the actual size of things. I mean, people don't complain about the U.S. interstate system, if maps of that, the roads being the exact same size. It's a reality that the Earth is huge, and humans are very small, and human scale things are very small. So yeah, obviously we have to exaggerate stuff, but I would say actually the big thing that came from Tufty's tweet, the thing I enjoyed the most was really like the great outpouring from the community of people who said like, "Hey, what are you doing?"
Yeah.
Like,
Yeah.
like at the time, I had like I don't know 9,000 followers, and maybe Tufty looked at that and be like, "Hey, this guy's like 1/10 of a Tufty because
Right.
he had 100,000 followers. Like, that makes him a fair game." I don't, but I think a lot of people saw it as like a punching down, which sure, I mean, but from there, like so many people came out, and I was working at the time, so I was like, okay, by the end of the day, maybe I'll respond.
Right.
But within like 2 hours, anything that I could have said, the community had said all like all people had come out and been like, this tone isn't great. Like, what are you
Yeah.
doing? Like, this is a great visualization.
Right.
Like it's lots of people it's like shared it with like saying like, wow, this is like I didn't never known
Yeah.
this is what had ran the internet.
Right.
Which I think is a sign of a good visualization. People have been like, oh my god, like I had never known this, and now I realize that this is the infrastructure that the Earth runs on for the internet.
Yeah.
It just I didn't really have any negative responses other than people saying, kind of looking the sort of same criticisms Tuffy was being like, I think some people might misunderstand this based on some other things, and I don't think anyone really did.
Yeah. I
Um,
mean, it's interesting, right? Because if your goal with that visualization is, I don't know what the companies are, but to lay, if you're working for a fiber optic cable network and seeking to lay new line, then that's not the visualization you want to use for that particular job. But if you
yeah,
just want to
no,
get this sense of what the world looks like in this sort of hidden layer that we all just kind of take for granted, that visualization, and I hate to say tells a story because I, have
yeah,
a problem with that phrase, a different story, a different whole conversation, but it does
yeah, yeah.
tell that story pretty quickly and intuitively.
Yeah, no, and I think that's kind of I think that's why it kind of hit such a nerve.
Mm,
Like the fact that a data visualization. I mean, I've had some things go viral on Reddit before. Some things will reach like the very bottom of the front page because data visualizations. I mean, I don't
yeah,
think most people think about them too much but hitting like the top
yeah,
spot, like opening up the Reddit app and like
seeing it
seeing
there.
it like right at the top, like that's the front page. That's above the fold, whatever the modern version, above the
Right
scroll
above
or
the
whatever
scroll,
that
yeah.
is. uh to see that in like the kind of top spot, I'm like, oh, this is really like touched a nerve
Yeah,
of people being like, oh wow, that this has made me like understand my world a bit
right,
better.
right.
So like that to me is like the end goal of a good data visualization is to get somebody to understand some data a bit better and to really like learn something. And there's kind of like these technical, sort of. I think a lot of data visualization gets criticisms often get caught up in kind of the technical considerations
Hmm.
of what is the best way. A lot of mapping is like projections
Right.
um but I think in a lot of cases uh you can tell a good story um kind of you can tell a good story without really the kind of sorry, I would say the here let me, you mind if I
No,
stop?
that's fine. Yeah, so just we'll do a
um
quick like quiet pause and then just start up.
yeah um okay, yeah, I would say the negative kind of technical considerations often I think don't come into play if you're tailing like if you have a really engaging data set, which I think is what the submarine cable map really was.
Hmm.
I mean, this data had been freely available and had been visualized in kind of a flat Earth um, before. I mean, you could see it. There are multiple websites that showed this data, but I think kind of showing it in the sense of more of a kind of realistic view of what the Earth looked like in this 3D view kind of made it a little more uh, grounded. It wasn't just lines on the
Yeah,
planet. It was showing how we were all
yeah,
connected through this web. Like I think in a lot of cases, kind of these network visualizations, um, it, it's the abstraction of the lines over the Earth. Kind of the fact that with many maps, the lines represented by the countries and the coastlines you have to sort of be able to separate them to the reader.
Yeah.
So moving it to 3D, I was able to actually physically do that.
Right.
The lines floated above the earth, so then you're able to see that, and it was sort of using this technical trick of 3D to kind of get beyond that sort of like, oh, what's the data here, and what's the point of the visualization?
Yeah.
Um, I don't know why this one kind of struck a nerve as much, but I think just generally 3D can create these really engaging plots because it can create like really beautiful visualizations. And I think that can really kind of enhance sort of these even data that not necessarily needs the 3D to like represent it. You could just plot this on a 2D map and it would represent the exact same thing.
Right.
But seeing it in this 3D view, I think just really, made it that level of engaging that people would actually see it and sort of be like, oh, this is my Earth, my planet. I don't know. It's. I don't know why things go viral.
No, I think it's impossible to know, but I think you've touched on a few of it. I mean, I'll just give you like my 2 cents. Like for me, I think why it struck a nerve. I mean, in the dataviz community, it struck a nerve because of the Tufte thing. But I think more generally, it struck a nerve. I think your choice of colors was something that made it pop. So, they were very vibrant, almost fluorescent colors. So I think those popped.
Yeah.
But I think your point about there is something about the animation of the globe spinning that in some ways it creates this reveal of this underlying network that we see across the whole world. And if you see it on a 2D static map, essentially, it's essentially lines across this thing. But there's something about that animation as it spins. You're like, oh, I can track this bright green line from New York to Berlin to Moscow, and I can see that. And I have to sort of wait for that to happen and sort of reveals itself. And I think that's part of it.
And that actually brings so the next point I kind of wanted to talk about 3D was so 2D visual dataviz I think has a lot in common with has a lot of crossover with illustration.
Mm-hmm.
So like a lot of aspects of art, color theory and that you need to use when you're doing dataviz in 2D. And I think a lot of illustrators are often like very good at dataviz when they get into it. I know like Ali Torban.
Mm-hmm.
I think she's a very good illustrator and she makes very good data visualizations. But I think 3D is interesting because it actually has a lot in common with cinematography. You need to actually use a lot of techniques that cinematographers use. In that, like the slow reveal. In rayrender, you actually have to worry about where your depth of field, where you're focused.
Right.
You have to worry about lighting. You have to do light design, and it's actually a lot more related to how you film something and reveal something in an actual like movie or TV show than just the kind of flat static nature. Now you also have interactivity. Yeah. So a lot of those are the kind of the two choices you have in 3D. Whether you want to make it like a fly through video game style experience where you're flying through the space and revealing it that way, or you can do this animation approach. I think interactivity is a bit harder for technical considerations, just because one, you have to deliver big 3D models to people, and that can be hard from a just pure web bandwidth point of view. But also it's just hard because a lot of people don't really work in 3D space that well. I'm part of the Nintendo 64 generation, so I know how to go back and side to side, up and down. But I think a lot of people, and even a lot of people my age, just don't really do well in 3D because it's hard. You have lots of degrees of freedom. So interactivity is good in some senses in 3D, but it's actually much harder to implement correctly. But movies, I mean, one, it's easy to share a movie on social media. You can embed in a movie on Twitter. All major social media sites support embedding videos, which is why I think animation is really my preferred method of sharing 3D visualizations. And two, then it allows you, the creator, to sorry about this, tell a story rather than kind of having the person walk through what kind of story that you think you'd want them to tell. It's much harder than 3D because you just have a lot more places they can go. One of my visualizations that I made this past year was I actually made a VR roller coaster ride. It's sort of a demo proof of concept of the technology, but where you'd have a 3D data set, and you could actually you take them kind of on like a monorail tour through your data, and that kind of bridged the gap in that it was actually just a movie.
Yeah.
So for me, I was able to render all the frames, but it was a movie rendered with a 360 view. So if you had VR goggles, you could put them on and then kind of look around as you were traveling through the scene, which kind of splits the difference. I really like that, just from a if you look at a lot of 3D tours through data that like the New York Times have done, they've kind of combined scrolly telling with this sort of 3D tour where as you scroll, the camera travels through the space. And kind of, I think this element of interactivity with the VR aspect is kind of splitting the difference. And that's kind of as far as I would probably go with it. Just because, it's like a movie that, where they can look around. But yeah, generally speaking, I like movies just because it really, the technology is much well supported. It's a lot easier for me to put together, and it's really a lot better for, I think, the end user, at least for now.
Yeah. Well, that's cool. So I'm now eagerly anticipating your next VR R package in 2022, and I'll have to go buy whatever the metaverse decides to put out and let me purchase. Tyler, thanks so much for coming on the show. This has been great. Really interesting stuff. And I'm glad you were able to brush off the Tufte criticism, because that can be a tough pill to swallow when someone like that does that. But I'm glad to see this work. I'm glad to see people using it. I've seen it more and more now, which may be just me sort of having my eyes opened a little bit. But it's really great work. Congratulations. And yeah, thanks again for coming on the show.
Yeah, no, thanks for inviting me.
And thanks everyone for tuning in to this week's episode of the show. I hope you enjoyed that. I have put the links to everything that Tyler and I talked about in the show notes, so you can check out the R packages he created. You can check out the tweet from Tufte and the various responses to that. And just more generally, you can go play around with some 3D. So until next time, this has been the PolicyViz podcast. Thanks so much for listening.